Hey guys, this is a lesson for finding the volume of a prism with fractional edge lengths. So really what we're practicing here is using these two, let me get my highlighter here, these two formulas to show volume. And our fractional pieces are going to be helping us practice multiplying and dividing by fractions. Okay, so let's go ahead and look at this first problem here. It says a reptile tank is a right rectangular prism. The tank is 1 foot long, 3 feet wide, and half a foot tall. So we have our dimensions here, and it says, what is the volume of the tank? So because I have all three pieces, I'm going to quickly write down my formula. So we said that it was length times width times height, or we could have used volume equals base times height. So because we're looking at the volume, we have a capital B or a big B here because we're looking at the area of these two. So we've already multiplied those together. But since we haven't done that, we're going to go ahead and use volume equals length times width times height. So they gave me all of those dimensions, so I'm going to go ahead and just plug those in. So volume equals the length, which is 1 foot, the width, which is 3/4, and the height, which is 1.5. So we've just gone ahead and plugged those in. So just for clarification here, we have 1 foot long. That's the same here. 3/4 of a foot wide. Plug that in right there. And then finally our height, how tall it is. Okay. So we have all those numbers in there. Now we can go ahead and solve those. We're going to use the order of operations going from left to right. We have multiplication here, so we'll start with these two numbers here. So 1 times 3/4 is the same as 3/4. And then we're going to go ahead and multiply our next one, just keeping on going over. But if you see here, this is a mixed number, and we don't really want to work with a mixed number. So we're just going to change that to an improper fraction. So I'll do the little roundy-boundy way here. So what I like to do is say multiply and add over your denominator. So we'll keep our denominator, which is 2. 2 times 1 is 2, plus 1 is 3. So really, we're multiplying 3/4 by 3/2. So I'm just going to go ahead and multiply my numerators across. Okay, so just like this. So 3 times 3 is 9. And then I'll do my denominators the same. 4 times 2 is 8. We have an improper fraction here. Our numerator is greater than our denominator. That tells us we have more than one whole. So what I'm going to do is pull out as many whole pieces as I can. And I know my denominator is eighths. So I'm going to count by eighths. 8/8. Can only get 1 in there. If I had 9/8 and I subtracted 8/8, I would have 1/8 left. So I can make this 1 and 1/8. Woohoo! Okay, so just a brief overview of what we did here. Okay, and in the form of a picture. Okay, and number 2, Mariko is building a raised garden bed. The garden bed is a right rectangular prism with the dimension shown. How many cubic feet of soil does Mariko need to fill the garden bed? Okay, so we know that our base part, our bases are here. So we have length and width. Okay, and then the height. Okay, so we're going to go ahead and use volume equals length times width times height again. Okay, so we're just going to plug in our values here. The length is 2 1/4 times the width, 3.5, and then the height. Okay, before I even get started, I know that these need to be dealt with. Those need to be changed into improper fractions. So I'm going to go ahead and just redo those real quick and then just bring everything right on down. So 4 times 2 is 8 plus 1 is 9/4. I really don't like doing the roundabout way. So when I talk about roundabout, is doing it like this. I feel like it's a trick. It doesn't really show you what the number means. It is quicker. However, we want to think about the value of the number. So I'm going to stop and show you because it's important. We're looking at the denominator. We're counting by the denominator to find out how many whole pieces we have. So 4, 8. because we're counting up to that whole number. So I have 8/4. Bring down your fraction friend, which is 1/4. Add those together, and we have 9/4, which is the same thing. The more practice you get doing it the fractional way, it'll be as fast as the roundabout way, but just want to bring your attention to that. Okay, so we have 9/4. Then we'll go ahead and look at 3/2. We have 6 and 1, which is 7/2. And then we'll go ahead and bring down our 2. Okay, so what we're going to do here is we're going to start off by going from left to right. So we'll multiply these guys together. So 9/4 times 7/2. We'll just go ahead and multiply straight across. 7 times 9 is 63. 4 times 2 is 8. Okay, we're going to keep it improper because we're still going to multiply. We know that this is 63/8, and now we're going to multiply that times 2/1. Okay, we're just bringing down this guy right here. Okay, so we've multiplied these, and now we're just going to multiply this one. So 63 twice. I'd like to think, so when we're thinking about math and fluency and how we can multiply very quickly, I like to think about decomposing the number when I'm multiplying a multi-digit number. So it's really 6 tens and 3 ones. I can quickly do that in my brain. 2 times 6 tens is 12 tens, which is 120. So this is how I do my mental math, which is 120. So 2 times 6 tens is 12 tens, which is 120. And then 2 times 3 ones is 6. So we have 126. And then our denominator is 8 times 1, which is 8. Clearly here we have an improper fraction, so we're going to need to do some long division here. This one doesn't lend well to really counting by 8s to get to 120. So we're going to do this one as a long division problem. So we'll do 126 divided by 8 to get our number here. So 8 goes into 12 one time with 4 remaining. Bring down your 6. 8 goes into 46. Pretty close. We're going to go 5 times, which is 40, and have 6 left over. So that means that we have 15 and 6/8. 6/8 can be reduced. And we'll do 15. 2 goes into 6 and 8. So we'll divide those by 2, and it becomes 15 and 3/4. So the volume of our rectangular prism is 15 and 3/4. Looking at number 3, it says a right rectangular prism is completely filled with small cubes. Each small cube has edges that are 1/4 long. The volume of the prism is 5 inches cubed. How many cubes does it take to fill the prism? So we need to think about a few things here. We need to think about if each one of the edges has 4 pieces, has 1/4 pieces, and it eventually ends up being 5 inches cubed. How many cubes do I need? So I'm going to draw myself a little prism here. I'm not that great at drawing 3-dimensional shapes, so you'll have to excuse me here. So you can kind of see here we have a height, we have a width, and a length, right? So we need to think about, it's telling us that as I'm filling in these shapes here with cubes, it's telling us that these fractional edges right here of the cubes are 1/4 inch long. Okay, so if I know that, and I know that it's going to end up being 5 altogether, what do I know about how many pieces those have? Okay,